All right, and we're COMP1050 Animation 2D Tools, Week 7, Part 3. Okay, we're talking about using math to rotate and move objects. We're going to kind of fly through this one. We kind of did it a little bit when we did Python, but we're going to do a few things a little differently here in ActionScript because some of the stuff we're doing here, the coordinate system, well, if you will, is slightly different. We'll see that. So we're going to use sine, cosine, and arctangent in order for us to move things around. So again, we used dx and dy to define the difference in horizontal and vertical positions, right? Dx and dy, right? Almost a change in position, if you will, or difference in speed. So again, an object moving of a dx of 5 and a dy of 0 was moving 5 pixels to the right because that's our coordinate system, right? But what about if we start rotating? And remember what I asked you for your assignment or your next assignment, which is project number 1, is 8 directional movement. That's one of your your requirements. So in order for you to do 8 directional movement, realistically, you need to rotate, right? In order for you to rotate, and even if you go in a 45-degree angle, as an example, so let's say you change you have your player, and your player can move, right, left, up, down, and maybe you can move at an angle, like 45 degrees up, 45, top right, bottom left, so on, without actually moving at an angle, not just going up and to the right, kind of thing. We don't want that kind of movement. How do we do that? How do we find out those, the angle that we're moving? Well, we use these math, sine and cosine functions, and whenever we use the math functions here in ActionScript, we don't need to import a library. It's built in. So math.sine, math.cosine, math.arctangent, math.pi, all that stuff is built in. Kind of makes it very, very powerful as a base package. Let's take a look. So remember, in the past, what we had was, in our coordinate system in Python, in other game systems, we had to the right was east, if you remember. This was north, right? And if you notice, we would go in this fashion. When we go 90 degrees we turn 90 degrees left, we go this way, and we go north, right? But the challenge is now, when we go 90 degrees, everything happens in a clockwise position, starting at this position at 0, 0, right? So this is east. And when we say 90 degrees, we actually go down 90 degrees now. And again, up when we go to 180, up to 270, and then back to 360. So it's a little bit different than what we did. It's actually reversed of what we did in Python, right? So, and the rotations all work that way too. So you can get rotation. You can say rotate 30 degrees, right? But sometimes rotating 30 degrees is only one part of the equation. If you want to get accurate movement, not only do you have to rotate 30 degrees, but you also have to move your object, your ship or your alien or whatever, a number of pixels in a particular angle based on the rotation. So how do we get there? So what we want to try and do is, again, we want to use radians. And again, radians are 360 degrees, right, multiplied by 2 pi radians. Right? So that's how you get, the angle, right? So example would be 180 degrees is 3.14, right? So 360 degrees, that's pi, right, is 6.26 radians. And so we measure things in both in radians and in degrees when we do these calculations. Okay, so again, these 4 directions, they're easy to figure out with math.cos and math.sine, right? In terms of angles, though, we got to figure out how to move around. And what we normally do is with math.cos and math.sine, cosine and sine, or sine and cosine, however you want to see it, they always return values between -1 and 1. One of them gives us the x-coordinate, and the other one gives us the y-coordinate. That's why we use math.cos and math.sine. That's what they do for us. Okay? So an example would be, so if an object is 57 degrees, right, at 57 degrees, what's 57 degrees now? If I go back up, 57 degrees is down here, right? This is around 57 degrees in here, right? Because here is 90 degrees down here. So somewhere down here is 57 degrees. This is where 57 degrees is. And if we want to get there, we get from our sine, our cosine and sine, we get 0.54 and 0.84. And if we're moving at a speed of 5, we multiply those values by 5. So we know we're going to move to the next position is going to be whatever our current position is plus 2.7. Add 2.7 to the x-coordinate and add 4.2 to the y-coordinate, and we're moving actually to the right, down and to the right direction. But we're going the exact number of pixels we need to get to the next location based on our angle, right? And that's how we do. We use math.cosine and math.sine. So let's take a look at the first example, which is moving a car with sine and cosine. Okay, so we're going to do that. We have moving car.fla and moving car.as, and that's in part 3 of our code archive. So here's our car. If I run the program, if you notice, our car is pointing in the easterly direction. This is 0 angle, right? If I actually use my arrow keys, I can rotate left and right. Right, it moves quite quickly if you notice, right? So it keeps on rotating forever, right? Same way on the way back. If I use my up arrow, it goes forward. Now it stops. There is no deceleration, acceleration, and there is no way back. If I click my back arrow, it doesn't come back. It's gone, right? I've turned around and maybe come back. Maybe I'm lucky. Probably not, right? So that's our car. Well, how do we do that? Well, we have a couple of things here. We don't have a car class, but we do have a document class called movingcar.as. So let's take a look at that one. Okay, so not a very big class at all. First thing we do is we have our constructor called movingCar. We don't accept any parameters in the constructor. We have a instance variable for left arrow, right arrow, and up arrow. And again, those instance variables are all Boolean. Are we moving up? Are we moving left? It's actually a string we're going to wait for. It's a true or false value, right? Right now there's null. All of them are null. We don't have a true or false, right, for any of them, right? We create enter frame event, which is we're creating this game loop, if you will, that we're listening to each for the car moving. We're moving at 60 frames per second right now, and we're also listening for key up and key down events for which keys are pressed. Okay, so depending on which key is pressed, if I lose the left arrow is true. So we say, okay, so we're moving left, right, as an example. And we decide which arrow is true depending on what the key code is. We don't actually move in this function. We just say which key is pressed, left arrow, right arrow, and so on. Same thing with the key up, key presses up. So either, depending on the key press, left, right, and so on, we determine which of the Boolean parameters here in our instance variables are set to true. Okay, that's what we're going to do. Okay, that's the first thing we do. Then we're going to actually move car. So depending on which arrow was pressed, here's our move car function. We say, well, if the left arrow is true, then my car rotation is going to be minus equal 5. Which means I'm going to move to the left counterclockwise 5 degrees. So our rotation, our angle of rotation, our speed of rotation is pretty quick, 5 degrees every time, right? It's an even 5 degrees. Same thing with the right. If I click the right arrow, then I'm going to move to the right 5 degrees, or clockwise 5 degrees, right? If I use the up arrow, I want to move forward, so I'm going to call the move forward function. Right, so that's pretty simple. The rotations happens like 2 seconds. I can just use the rotation method of the car class that I'm moving, right? Moving forward is another story altogether. Moving forward is where I do all my heavy lifting. Okay, so here I have a speed of 5 as an example, 5 pixels per frame, right? And my angle is 2 pi, right? 2 pi radians. That's what this is, because pi, when you get this in radians right now, multiplied by the rotation, the angle of rotation, divided by 360 degrees. So if I say I move to the right 5 degrees, and I only press my right arrow once, As an example, I'm at 5 degrees. I take 5 divided by 360, multiply it by pi 3.14, 159,786, and so on. And then multiply that by 2, and we get our angle in radians. That's what we get. We take that angle in radians, and we plug it into our cosine function to get our change in x value. And we do the same thing with our angle in radians, and we plug it into our sine function to get our angle in for our y value. And then we change our x value and y value by the dx value, the change in x and the change in y. Okay, so we actually add it to our current location. And that's how the car moves to the right and to the left. But we don't have a move backward. We don't have a move backward function, right? And right now, what I'm doing is I'm actually polling, right? I'm polling for key code 39, 37, 38, and 39. What's the down arrow if we wanted to make it go backwards? Who knows what the down arrow key code is? How do you figure that out? If I want to find the key codes for all the key codes for ActionScript. Well, look it up on Google, right? So I just go here, ActionScript AS3. I can put in AS3 key codes, right, as an example. And then it's going to take me to my key code list. I'm just going to hit one of these sites here. And if you notice, these are all the key codes that you need. So here's my down arrow, which is 40, right? So my down arrow is 40. I'll go back to my code. Let's create my down arrow. So I've kind of done my my down event here, right? And I want to create my down arrow, but it's definitely going to be a Boolean value going with this framework, right? Up arrow. Let's make a new one called down arrow. Here's down arrow, right? As a Boolean value, right? And we need to respond. So else if, we'll put another else if in there, right? Else if, okay, if key code is key code 40, right? Because that's key code 40, then down arrow is equal to true, right? I'm going to copy that little piece of code right there, right? So like that, and go here, and I'm going to say else if event key code 40, then down arrow is false. Down arrow is false because this is our key up event, key press stop, right? Down arrow is equal to false, right? So that's what's going to happen there. Okay, so now we've got our down arrow. We're listening to down arrows, but now we got to do something if my down arrow is moving. So I'm going to kind of take this up arrow, and I'm going to put in there. Oops. I'm going to put in something called down arrow. Here it is. Here's my down arrow. When I can move forward, instead of moving forward, that's cool, right? But I want to do the same thing, but I want to move back, right? So instead of me going in a turning my car in a positive direction, right? So right now my speed, right, as an example, is 5. All I want to do is change my speed to -5, right? Because I want to go kind of in a negative direction, right? So my speed is the thing I got to change, right? And what I need to do is kind of say, maybe what I want to do is pass in a variable, a direction, right? A direction, right? So I can do a couple things. I can say I can pass in into this parameter. I can pass in forward or back. I can do that instead of writing a whole new function, because I don't want to write a whole new function. It's exactly the same, right? So maybe what I want to do is which direction am I going to? Am I going forward or back, right? Or I already have up arrow and down arrow. I know I've got these up arrow and down arrows that's the last thing I did. But I want to know that when I've got my up arrow pressed, I move forward, and when I got my down arrow pressed, I move back. So let's do this. So var speed number. Okay, we'll put this in here like this. So we've declared a speed, but now we're going to say this. We're going to go if, right? If up arrow, if that's true, because up arrow is a global variable or instance variable, if you will, right? If up arrow, well then I want to have my speed, right, is equal to 5.0. So speed right, is equal to 5.0, right? We know that for sure. And then if we say, we'll do the same thing. If down arrow, if that's true, well then speed is equal to negative 5.0, right? So all we're going to do is we're going to take the speed, the negative number, multiply it, and we're going to get a negative dx value, which is going to back us up. That's what's going to happen. Okay, let's see if this works. So I'll save it, right, and I'll run it. If everything goes well, I should be able to go back and forward now. I can move up on the screen and come back onto the screen and kind of rotate around. So it's kind of a very simple, quick solution, modifying our code to move now in all 8 directions, forwards and backwards. All right. I'll let you guys look at the PowerPoints if you want to look at that more closely. We can actually do it the other way around. With arctan, right, we can go the other way around. We can go, okay, here's my angle, right? So from an angle to an x-coordinate. It's going the other way around, right? And a good example of that would be if I have, so it gives me x and y coordinates. And most times, I'll be honest with you, we'll use x and y coordinates for a lot of our movement. Where are we moving next? X and y coordinates. You're going to use this move function we just saw for the car, right? But the arctangent, right, function works the other way around, right? If we have, so here's point 1. Point 1 is located on our grade at 6, 5, right? To find its angle from you, so the angle from you, right, where you are from the center, I want to find its angle. Why would I care for the angle, right? I want to find the angle from me to them, like within 30 degrees. Well, sometimes it's all about firing arcs, right? We make a game, and your game has a certain firing arc. Example is, you can't fire at this object because it's not in your line of sight. Because line of sight is a big one when it comes to computer games, even with AI, right? Well, here is this object. Is it within my 30-degree arc for seeing it, as an example? If it's within 30 degrees or 180 degrees. For example, I only have peripheral vision when I'm walking around, and it's only at 180 degrees. I can't see, well, approximately, maybe a little bit more than 180, because our eyes are made to see slightly more than 180 degrees. That's why our eyes are slightly at the side of our head and in the front, right? But birds can see pretty much in almost a 360-degree arc, right? Because birds' eyes are at the side of their head, mostly, depending on the bird, right? So they have a much wider arc, a much wider field of view, if you will, right? So this could be a good way of using AI to say, does he see me? Can the AI see me? Yes or no, right? Well, if my object, here I am, is within my 30-degree field of view, well, then maybe this AI, simple AI, sees me. If not, it doesn't see me and I sneak by. Well, how do we do that? We say, well, here's a point, and I want to get an angle from the point. So here's my point 6,5. To find its angle, we take the y distance and the x distance and feed them into this math.arctangent2 method. And what it does is we get 0.69 radians, or about 40 degrees. So we convert radians to degrees. We get about 40 degrees difference from this 0.65, right? So the arctangent likes to keep numbers between negative 180 degrees and 180 degrees. And the way it does that is anything to the left is on the negative side. Anything to the right of the horizon is to the positive side. Let's take a look at a really good application of that with pointingarrow.fla. I'll go back here. I'm just going to close this off. And we're going to look at pointingarrow.fla in our code archive right inside of our rotation math part 3 code archive. All right, so how does this work? Well, depending on where my mouse is, it's like a follow mouse program. It kind of follows me around, points to where my mouse looks at. Right here I am, looking left and right. And depending on where I am, the mouse looks at me. Right? This is kind of cool. How do we do that? Well, actually, there's a really simple way, stupid way to make it happen. Right? If I want my cursor to follow me around, that's one thing. But if I want the object to look at me, have eyes on me all the time, example AI again, right, where I have an AI looking at me, so it's got line of sight, and me, being me, is the mouse, right? There's a good way to calculate it the other way around. Let's take a look at it. So here's pointing arrow.as. Okay, again, it's a movie clip, and we have the actual arrow is a moving clip. So let me take a look at the arrow. Here's the arrow, right? The arrow is just a big arrow, right? And the arrow is set up to point to the right or easterly direction, or the 0 angle, if you will, right? Okay, here we are. So once we instantiate the arrow, as soon as we instantiate the arrow on the movie clip creation, we create this enter frame event that says point at the cursor, right? Well, here's this point at cursor event. We say our dx, our delta x, right, as an example, is a number which is the mouse x position, my mouse x position, minus my pointer dot x position. Okay. Remember that the arrow itself, if I go back, right? If I go back and I look at, if I click on the arrow, so here I am on my main movie clip here, right? And on my timeline, right? And I'm looking at it. I've instantiated this object arrow, right? It's a movie clip, and the instance name is called pointer. That's what it's called. That's how I can follow it around. So if I go back, so my pointer.x. So think about this. I take my one x coordinate and I take the other x coordinate, subtract them. Now I've got the distance of the line between my x and that's how fast it is, right? It's very, very simple how to find the distance, right? Same thing with my y. Here's my y coordinate for my pointer. Here's my y coordinate for my mouse, and I can find the distance. Now we're not printing those out, but let's just do that as an example, just for giggles, right? So we'll make a trace statement right here, right? And we'll say dx, right? We'll print out dx, right, plus dx. That's what we'll do. We'll kind of add that in there. And we'll also do another trace statement, right? dy plus dy. So we'll have our dy and dx kind of showing as we move our mouse around now, right? So here we are, look, right? So 84 and 54. That's the distance from my mouse to the cursor, the middle of the cursor, right? If I move my mouse farther away, right, the numbers change, right? So it gives me the distance between my cursor, my mouse, 254, 260. It keeps moving farther away, right? Same thing if I come down here, right? Or if I go closer. If I go closer right to here, as you can see, my dy coordinate is a negative value. Why is that? Why is my dy coordinate a negative value when my cursor's there? Anybody? Yeah.
Because you're over top of the image of it, so it's going to be a negative number?
It is, because I'm on top of the image, right? But where is my angle of rotation? Looks like my rotation angle is right in here, look. Right, if my cursor's right on top of it, I should have 0, 0. There's my 0, 0 point, right? So as I move to the right, as an example of the cursor, here's my angle to the cursor. I'm keeping my mouse as steady as possible. So my dy value, oops, there it is. If I go above the median, above the horizon, remember I talked to you about this, above the horizon, my delta y value is a negative value because I'm going higher in value than my original point, which is the middle of my pointer. And if I go below my horizon, so here's my horizon, if I go below my horizon, my number for my dy value is going to increase because I'm actually lower, a greater distance than than I was before. So it kind of gives me my dx and dy values, which is kind of cool. Okay, that's the first thing I can do. Let me just erase those. Okay. The next thing I say is this. My cursor angle, here I'm getting my angle now, is I take my arc tangent takes dy and dx, has to be y and x like that first, right, and spits out a number in radians. That's my angle in radians. And then I multiply my angle in radians, right? I take 360 degrees, multiply my angle in radians divided by 2 pi, right? And then I get degrees, right? And then what I say is, depending on what my cursor degrees is, that is my rotation angle for my pointer. So I rotated the exact angle that I get depending on where my cursor is, compared to the middle of my pointer. Okay, that's how we do it. And again, great way of determining where I am from an AI perspective. Okay, so imagine if this thing is tracking my cursor, right? And I only have one of these things moving at me, right? But remember, I can create multiple instances of the same object that they can do the exact same thing, right? So I have, in this particular case, I have something called pointer, right? But instead of pointer, I can create an object. I can have an object class that I use at create. When I instantiate my object, it's called, whatever my instance is. It's an array. I have an array of these symbols, and they all point at me. They all fire at me at the same time. And I kind of did that as an example one time in Python, where I have, I had these hunters, and my cursor had a wolf, and they're firing at the wolf. I don't know if you guys remember this, right? And I did that simply by using the same kind of algorithm. All right. Oops. So we kind of explained most of this stuff here. When we cut back, we're going to talk about air raid 2.